all, my name is Ayush Bisoy from grade 8, and now we are going to study the second part of the chapter square and square roots. Last week I sent a video which is the part 1 of this chapter, and in that chapter I explained all the important patterns and how to find square. Now we're going to the second part of the chapter, that's square roots. We'll be learning how to find the square roots through the 3 different ways, and we'll also learning what is a square root and how to estimate a square root and what are its properties. Okay, so let's get started. What is a square root? Square, we have been learning that the opposite of plus is minus, opposite of multiplication is division. Just like in the same way, opposite of square is square root. So square root is the number which we are going to multiply twice, so we get the square number. For example, now 16 into 16 will be 16 square, that is 256. So when we try to find the square root of 256, it will be 16. So the number which is being multiplied to find the number which is being multiplied to find the square, the opposite of that is 16, so that is going to be the square root. So just like that, how you have to understand how minus is the opposite way of plus, or how division is the opposite way of multiplication, just like that square root is the opposite function of a square. So now another example, now if you say, so 10 square equals to 100, so square root of 100 is 10, so it's the opposite. Okay, now we'll be seeing the properties. So now we'll be seeing the properties of square roots. Just like how we learn the properties of square, like that we'll be learning the properties of square roots. As the square root is the opposite of square, so the properties of square root will be also the opposite of what was for the square. So the first property is square root of any even number. Even number will always be even. Like we saw, the square root of 256 will always be 16. Or if we find the square root of 144, so that will be 12. So just like that, the square root of any even number, so the square root of an even number will always be an even number. So, and another is square root of odd will always be odd. Like square root of 9 will be 3. Or square root of 49 will always be 7. So second one is there is no square which is negative. We know that if we multiply a negative into negative, so it's always going to be positive. So even if we multiply positive with a positive, it will be positive, and if we multiply negative with a negative, it will be a positive. So there is no square which is a negative number. So hence there is nothing like a square root of a negative number, as we know. So this the second thing says that there is no square root of a negative number. Third one, if the number ends with odd number of zeros. We learned in the properties of square that if there are odd number of zeros, it's not the number is not a square, because there should always be even number of zeros. Because for example, now if there is 1 0 in the first number, like 10 into 10, so there will be 2 zeros in the end. So when we multiply, there should be an even number of zeros. So odd number of zeros is not possible. The next one says that if the square ends with 2, 3, 7 or 8, then its square number is not possible. Its square number can be in decimals, but a natural square number is not possible. So here in this chapter we are mainly talking about the square roots which are natural numbers, or which are not in decimals. So any number ending with 2, 3, 7 or 8 cannot have a square root which is a natural number. Now we'll be seeing a table now. So while learning the properties of square numbers, we also saw a similar type of this table. So in that table, one side was shown the unit of the number, another side was shown for the unit digit of the square. Now here we will see the ones digit of square and what can be the ones digit of the square root. So if the square ends with 1, so we can determine that the square root will end with 1 or 9. As we know, 1 square will be 1 or 9 square will be 81, so it ends with 1. Now if the square ends with 4, then it will be 2 or 8, as we know through the properties of square. And if 5, then it ends with 5. And if the square ends with 6, then its square will be 4 or 6. So 2, 3, 7 and 8 are not there inside a square, because no square can end with 2, 3, 7 or 8. If any number is given with 2, 3, 7 or 8, then its square root will be in decimals. Now another is 0. Now if there are even number of zeros, as I told you, odd number of zeros are not possible. If there are even number of zeros, so how many zeros are there? It should be half of it. So this means that if the square has 6 zeros, then the square root shall have 3 zeros. As we know, we are dividing the number again by itself. So the number of zeros will become half. So that's why how many zeros are there? It should be half. And as I told, there are no odd number of zeros, so half can be done. Now we'll be going into finding square root through the 3 ways. First way of finding the square root is through repeated subtraction. So what is this? For example, now we take 36. So if we need to find the square root of 36 by repeated subtraction, so we will do first 36 minus 1, which is equal to 35. Then next we have to do 35 minus 3, which is equal to 32. So like how we learn in the square, that every square is a addition of consecutive odd numbers. So here we will be also subtracting them through consecutive odd numbers beginning from 1. And now through the procedure we will learn how to find. Next, 32 minus 5 equals to 27. 27 minus 7 equals to 20. 20 minus 9 equals to 11. 11 minus 11 equals to 0. So till we get 0, we have to keep on subtracting them with consecutive even numbers. Now we have to find how many steps we required. So this is going to be step 1, this is step 2, this is step 3, 4, 5 and 6. So we got 6 steps. So we can tell that 36 is the square of 6. So how many ever steps we get, the square of the steps is the number which you are finding. So the square root is 6. So mainly we have to keep on subtracting them with consecutive odd numbers till we get 0. And once we get 0, we have to check how many steps we require for finding them. So how many ever steps we require, that's the square root of the number. This is very good for small numbers. Now we go to the next way. So now we will see the second way. The second way is we can also find square root through prime factorization. We have been learning prime factorization for HCF and LCM from grade 5, and this is a very easy part. So now let us see. For example, they are telling us to find the square root of 9604. So we have to do the prime factorization. 9604 divided by 2, 4, 8, 0, 2 divided by 2, 2, 4, 0, 1, and this time by 7, 2, 4, 0, 1, 3, 4, 3, this time again by 7, 49, by 7 again, we'll get 7 again, 7, 1. So we get to know that 9604 equals to 2 into 2 into 7 into 7 into 7 into 7. So we get to pair each of these with 2. So we know square means multiplication of two numbers with themselves. So here we get 2 square, 7 square, again 7 square. So if we are trying to find this square root of 9604, then it will be square root of 2 into 2 into 7 into 7 into 7 into 7. That will be 2 into 7 into 7. That is 98. So here we are able to find it through prime factorization. So the square root of 9604 is 98. So this is very easy, but there can be many variations from this, or there can be many questions coming from this in a different way. So let us see some of these other examples. Okay, so the first variation which can come in the exams for this question is, they will ask you to find the smallest square number which is divisible by 9, 6 or 15. So if they give, so we have to find the HCF of 9, 6 and 15, like 9, 6 and 15. So first with 3, 3, 2 and 5. Then with 2, it will be 3, 1, 5. This time again with 3. So 1, 1 and 5, then 5. So it will be 1, 1, 1. So we get to know that the LCM of 9, 6 and 15 is 2 into 3 into 3 into 5. So here we have to again find the pairing, how we find it the last. So square means square means multiplication two numbers. So we should find the group of 2. We already have group of 2 in 3. Only we need to find for 2 and 5. So that should be 2 into 2 into 3 into 3 into 5 into 5. So we will get the smallest number. Here we need this 2 and this 5. So that means we have to multiply this. We need to get multiply these. So it will be, the LCM is 90. So that means we need to get 90 into 2, 90 into 2 into 5. Why 2 into 5? Because we need 1 2 and 1 5 to be multiplied, so there can be pairing between all of them. So it should be 90 into 2 into 5, that is 90 into 10, which is 900. So 900 is the smallest square number which can be divisible by 9, 6 and 15 each of them. Now we'll be seeing the other variations. Now the two variations which I will be showing you are very common in exams. So they will give you a number and tell you to find the smallest number which should be multiplied or divided from it to get a perfect square. For example, take 252. 252. So 252 is 2 into 2 into 3 into 3 into 7. And they say that get the smallest number which should be multiplied to make 252 into a square. So we know here that this and this 2 and 3 both have pairs and they are in a group of 2. So they form a square. But 7 is alone. Because of this, 252 is not a square. So we need to get another 7 so that it becomes group and a number can become a square. So 252 into 7 equals to 2 into 2 into 3 into 3 into 7 into 7. So here there can be groups. So the number will be 1764. So 1764 is gonna be a perfect square. And what is the smallest number required? The smallest number required is 7. So that means 7 is the smallest number which will be multiplied with 252 to get to make it a square, which is 1764. Now we'll see the second one. Okay, so now as I told, it could be multiplication and division. What if division happens? If division happens, you can do this. It's gonna be the same method. Just instead of getting a number, we're just gonna take the other number which is odd. So for example, we will take 252 again. 252, as I told, will be 2 into 2 into 3 into 3 into 7. So 7 is alone. If we take the 7 out, 2 and 3 are already in groups. So if we take this 7 out, then we can anyway get a square. So that means 252 divided by 7 equals to 2 into 2 into 3 into 3, which is, it is gonna be 36. So we get 36, and as we know, 36 is 6 square. So 36 is a square number, and here by dividing 7 we get 36. So here the 7 is the smallest number which is being divided to make 252 into a perfect square. Now we'll be seeing the next and the best method of finding a square root. Now, as we have seen here, that when we try to find square root of big numbers like 9604 or 529 or any number, when we try to find a prime factorization, then it becomes very lengthy and very big. And here, if you even miss one division or if you make a number mistake, then the whole number goes wrong. So because of this, there's a better way for finding square root of big and large numbers, and this is called the long division method, and this is mostly used in finding the square roots. So what is the long division method? We first take the number. For example, now we have 529. So 529, then we make like this. So 529, we make this into two parts. First, we get the 29 into one group and then 5. Here we start from the 9, from the units digit towards the left hand side to make groups. There should be groups of 2. Now if we get a number like 4489, then we'll make these two groups. We have to start from the unit digit and go to the right side while making groups, and these groups are going to be very important because from the groups only you can find the way. So 529, so 5 can be 2 into 2, so it will be minus 4. So here we have to find the squares. Now we have been doing division. Division is like this. So when we try to find a division, we also put a number here and another number here. So it's just going to be the same way. The only thing is that here, instead of numbers being multiplied from a multiplication table, here it is going to be squares. So it will be 2 into 2. So that's 2 square, that's 4. So when we minus, we get 1, and then we bring these 2 down, this group. It becomes 129. So how are we going to find from the other group? We will take the double of 2. Double of 2 is 4. So the number is going to be something like 40 something. Now we know 9. So what is going to be 9? 9 can be 3 into 3. So 43 into 3 can be 129, or even 47 into 7 will end in 9. So first you have to try for checks. For after doing checks you can find. Now you will go 43 into 3. 43 into 3 into 3 9. Then 3 into 4 12. So we get 129. So it will be 43 into 3 minus 129. So it will be 0. So we get the square root. The square root is 23. So this is the best way of finding square roots. So here first we make the groups into we make the number in two groups, starting from the units digit, groups of 2 number. Then we try to find the square of the most left hand side number. So here it was 2 into 2, which is 4, and here 5, so it's the closest. So 5 minus 4 we get 1, and then we bring the next group down, 1 2 9. Then we make the double of the number which we have got. Here it is 2, so 2's double is going to be 4. So then we try to find any number which is ending with 9. It's 9. So we know 3 square ends with 9, or 7 square ends with 9 using the properties. Here the properties come in use. So we have to check them. Now here we did 43 into 3, so we get 129. And if 43 into 3 was not working, we can check 47 into 7. And if it matched, then we can write here 7 and here 7. So here then it will become 27. So just like this we find. Now even these has many variations, and I will be showing you those variations right now. Okay, so how we saw in the prime factorization method, the variations are in multiplication and division. We find the smallest number which should be multiplied or divided to make it a square. Now, at times we get numbers and we are asked to find the smallest number which should be subtracted or added to the number so that it becomes a square. Just like, for example, we take 402. We know that 402 is not a square because it ends with 2. So that's why we use properties here. So we will do the L method, or the long division method, 402. So it will be 2 2 my 4, then it will be 0, and then 2 come here. So here we find that 2 is the remainder, as 2 cannot be taken any more further. So that means 2 is the remainder, and if we subtract 402 minus 2, we get 400. So here we have to find, so here we know that this is going to be the dividend, divisor, quotient, and this is the remainder. We have been using this. So when we subtract the remainder is the remaining number after doing the square root. So if we subtract the remainder from the number, then we can get the square. So 400 is the square, so we know 20 into 20. So here if the 0 is, if there is no 2 here, and we make it 0, so it will be 0, and 0 square is 0, so it's finished. We get 400 square root is 20. Just like this, there are more other questions like these also which come in the exams. Now we'll be seeing how to do in addition way. Okay, so there can also be asked like find the smallest number which will be added to make the following number into a square. For example, now we take 5 to 5. 5 to 5. If we try to find the square root, it will be 2, 2, 4 minus 1. We get 1 to 5. It will be 4 here, and here 2, and 42 into 2 will be 84. And if you subtract 84, we get 41. So here 41 is the remainder, but here it's not subtraction. Here it's a bit more complex. So we know that 22 square is smaller than 5 to 5. So we know that 22 square is smaller than 525, which is the question, because we get 41 remainder. The 5 to 5 is 41 times 41 numbers more than 22 square. But we also know that 23 square is bigger than 5 to 5. So that means 5 to 5 lies between 22 square and 23 square. And if we need to know the addition of the number, so the number gets increased. So that means we are going to find the 23 square. And what is 23 square? 23 square is 529. So here we get 525, and the next square is 529. So 529 minus 525 equals to 4. 4 is the smallest number required which will be added to make 5 to 5 into a perfect square. So what is here? We get a number. We need to find the smallest number which will be added to it to make a perfect square. First we are going to use the long division method and find the square root. The square root is 22, and we get a remainder. If we get a remainder, that means that the number given to us is bigger than the quotient. That means 5 to 5 is bigger than 22 square. But we can also know that it's not a perfect square, so it is less than 23 square. That's the next number. So that means 5 to 5, or the number lies between two squares. That is, here 5 to 5 lies between 22 square and 23 square. And as we need to know a number which is being added, we have to go for the next square. That is 23 square. Here 23 square is 529, which is 4 numbers larger than 525. So 4 is the smallest number which will be added to make it a square. Okay. So now we can see how where square and square roots are used mostly. Mostly square and square roots are used in formulas of algebra. Like sometimes it asks for a square plus b square equals to 36 or something like that. Or sometimes it's used in, mainly it's used in geometry for finding perimeter or area. Like a square. A into A is a square, that is a formula for finding the area of a square, or L into B, so it's going to be centimeter square. So mainly squares are used in geometry of finding areas. So that's why when an area is given, we can just find its square root to find the sides. For example, now if we get a square garden, if it says a square, if it has its sides and its area is 2304, we have to find the square root of 2304, which is 48. So the size will be 48. So like that. Some other extra questions can come like find the greatest 4-digit number which is a perfect square. So greatest 4-digit number is, as we know, 999, and 999 is bigger than, we have to find its square root. 9999, its square root is 99, as it's not a perfect square. So, and we get a remainder of 198. So that means 9999 is greater than 99 square. So, and we get 198. So we have to subtract using the property that we learned. So 198, 4 nines minus 198 will get 9801, which is 99 square, and 9801 is going to be the largest 4-digit number. Even these type of questions can come. So our chapter 6 of maths, square and square root, ends here. And this is a pretty big and complex chapter as we are learning it in grade 8. So best of luck for this chapter, because this chapter is really complex and hard. But if you thought that my video will help you, then thank you. Please subscribe, share and like it. Thank you.